Zydus is the discoverer of this molecule. Pharmacovigilance is the key. And we are trying to build up more data on the Indian population. Now, if you look at the West, if you look at people who are living in the developed countries, the coronary artery diseases, death rates in men aged between 65, below 65 from 1980 to 2010, if you see, they have started plateauing down now. And this is what is happening. Look at UK, the trend is going down. Look at Hungary, the trend is going down. But if you look at India, the cardiovascular deaths are absolutely on the rise. And you can see the trajectory is only going up. And therefore, we have a dual jeopardy. We know we are blessed with bad genes as Indians, but the nature and nurture story is more to do with lifestyle. It's got to do with urbanization, mechanization, diet, physical activity, tobacco, and clinical inertia. We also know, and this is a study which Salim Yusuf published in the Lancet long time back, the InterHeart study, that there are 9 modifiable risk factors for myocardial infarction. And the lipids, or the dyslipidemia, is the single most important coronary risk factor for myocardial infarction. So it's very clearly spelled out. In fact, if you look at others, it is smoking, which is number 2. It is psychosocial factors, which is number 3. Abdominal obesity, which is number 4. Hypertension is number 5. And then comes lack of fruit and vegetables, lack of exercise. Then actually comes diabetes. And then, of course, comes alcohol. And these are the 9 risk factors they looked at the InterHeart study. We had the opportunity this year to publish in PLOS One, where Professor V. Mohan is the originator of this ICMR INDIAB collaborative study group program. And under his guidance, 4 states of India have been mapped out, which is namely Tamil Nadu, Maharashtra, Jharkhand, and Chandigarh. And I was first author on this lipid paper, which looked at prevalence of dyslipidemia in urban and rural India on this study. The whole idea was that this was phase 1 of the study, not only to map prevalence of diabetes, but also look at the lipid prevalence. And as I told you, this represented around 18.1% of the India's population and around 213.5 million people. So this was the study, and it was a cross-sectional survey of adults about 20 years. It was done from November 2008 to April 2010. It was published a couple of months back. And I told you, South, West, East, Tamil Nadu, Maharashtra, Jharkhand, and a union territory from North India, Chandigarh was there. It looked at 16,000 individuals and above from 363 units, 188 urban, 175 rural. So around 5,000 population was urban, but a larger population, 11,495 was rural. And it was all ethically approved, used for high cholesterol and the abnormal ratios. Isolated cholesterol cutoff was 200, TG was 150, and so on and so forth. And then these were the diabetes, IFG, IGT, pre-diabetes definitions. These were the BMI cut points for India. And if you look at any lipid abnormality, and looked at BMI and waist circumference across states, you can see there's a very large predominance. As the BMI goes up, as the waist circumference goes up, you start getting lipid abnormalities. And that is very huge. So across all the 4 regions, with any lipid abnormality, there was a higher BMI and a higher waist circumference, except maybe females in Jharkhand. And if you look at the lipid prevalence from all the 4 regions, whether it's rural or urban, it was high cholesterol, high triglyceride, but low HDL, high LDL, abnormal ratios. So really, if you see across board, we had dyslipidemia in everybody, and I wouldn't go into details of that. But what is distressing is 79% of people surveyed had one lipid abnormality. Chandigarh was 82.9%, Jharkhand was 80%, Tamil Nadu was 76.9%, and Maharashtra was 77%. And if you look at the lipid abnormalities, only 20.1% or 21% of people had no lipid abnormalities. A whopping 72% of them had low HDL. So the commonest Indian lipid abnormality in general population, whether it's rural or urban India, is low HDL. The second commonest lipid abnormality which we have is high triglycerides, 29.5%, and then comes cholesterol, 13.9%. So we are so cholesterol centric when we are treating our patients, but let me remind you that it is the HDL cholesterol which is most prevalent in a community-wide survey which we have done. And you can see that low HDL, high triglycerides, 72.3%, 29.5%, and of course the high cholesterol is 13.9%, and normal people are only this. If you look at all the three abnormalities present in the population, 7.7% of adults had high col, high TG, and low HDL. So this was the age-specific prevalence of hypercholesterolemia, high triglycerides. So you can see very clearly, Indian problem is not cholesterol. Indian problem almost double or triple is triglyceride, and we all know that. We see this. And the bigger problem than triglyceride is low HDL. And we know that what is driving that low HDL? The low HDL is driven by TG and by the liver and by the lack of physical activity and the carbs. So very clearly you can see that females had significant higher rates of lipid abnormalities than males in urban areas compared to rural areas, except that hypertriglyceridemia was higher in males. Also, there was a clear trend. Cholesterol was higher in urban males, urban females and rural females. Triglycerides were very common in urban females and rural females. And the high LDL was more in urban females. So that is what was the data. So factors which were associated with all this were age more than 60, urban, high income, generalized abdominal obesity, fat and oil intake, diabetes, hypertension. And for triglycerides, what was most distressing is the age was not above 60. Cholesterol, the cut point was age beyond elderly people, but for triglycerides, the age was below 60. And low HDL, female gender, obesity, sedentary lifestyle. So our significant finding was 80% had lipid abnormalities, and it was in that order. Mainly the low HDL, then the high triglyceride, and then the high cholesterol. And there was some regional disparity, but I wouldn't go into details of that. But 80% of these individuals who had lipid abnormalities were in the prime time of their age, between 35 and 64. And they were females, obese, sedentary lifestyle, dysglycemia, diabetes and hypertension. And this is how it was. And therefore, when you look at another paper, which a couple of years back, one of my students, Rakesh Parikh, who's now in Jaipur in KEM, he had written up with us, prevalence of diabetes, 9 out of 10 diabetics in India have dyslipidemia, 85% and 97%. This was a KEM OPD paper. So should triglycerides be a target to reduce CV risk? And you can see here, this is data from Miller et al. Published in the Circulation in 2011. And very clearly you can see, if your triglyceride is less than 90%, your relative risk to die is 0.83. And if it is between 150 and 199, it goes up to 1.15. And if your TG is more than 200, it goes to 1.25. And if you look at total mortality, if your TGs are less than 90, it is 0.94. If it is between 150 and 199, it is around 1.09. And it will go, if it goes about 200, it becomes 1.2. So if you look at very clearly, triglycerides kill, whether it's all-cause mortality or cardiovascular mortality. Also, we know that is their data. And this was that data published just some time back in June 18, 2014 in NEGM. 75,000 patients, 34 years of follow-up. And they looked at risk of vascular disease. And they found that a non-fasting triglyceride, there was a loss of function mutation in ApoC3 gene. And you can see here, clear link between high triglycerides, non-fasting, and ischemic heart disease, published on 18 June on this. And you can see the hazard ratio very clearly there. And we have a Lancet paper on August 16th, published again. You can see very, very clearly the risk from the Copenhagen City Heart Study and Copenhagen General Population Study. As the TGs went up, the hazard ratio for myocardial infarction went up. Clearly, you can see it here, very, very clearly illustrated. So if you look at meta-analysis of 5 landmark studies, where they had used PPAR alpha agents. We know fibrates are PPAR alpha agents. We know Lipaglyn is a dual agent. It not only has a little glitazone and gamma effect on it, but it also has the alpha or fibrate effect. So it is one drug which has a mixture of fibrate and a glitazone put in its right ratio. And it is a substance which can work. So you can see a meta-analysis where a PPAR alpha agent reduced CV events by 35% when the TGs were about 200 and HDL was below 34. Typically an Indian problem. Because our Indian lipids are low HDL and high TG. So if you do that, in that population, you can see here very clearly a study which has been published clearly shows the odds ratio coming down if you reduce this. So TG lowering therapy clearly reduces CV risk when the baseline TG is about 200. So why are we all here? We are all gathered here to celebrate 1 year of discovery and launch of this molecule saroglitazar. And saroglitazar is a unique compound because, as I told you, it has an impact just like a fenofibrate on the PPAR alpha, and it has an impact just like a low dose pioglitazone on the gamma. So it takes care of the glucose, takes care of the triglycerides. So it's a 2-in-1 agent, and it is first in the time it's available any part of the world. Now, of course, they are doing trials outside of India. They are doing trials in Asia. They are doing trials in Australia. They're going to try trials in east of Europe, and then subsequently they'll move to North Europe and the US. But our problem, it is fundamentally addressing an Indian problem of diabetic dyslipidemia and regular dyslipidemia. Where our Indian lipids, because of our high fat, high carb diet and low protein diet, is predominantly low HDL and high triglycerides. And to address that issue, let us look at the clinical experience. We all know 16th September last year, they launched this drug. At that time, the PIO controversy was that it speaks and PIO ban had just been lifted out from India. But we know that it was the first drug from India to complete the journey from research to retail. Let us look at a patient registry program which saroglitazar had launched in November 2013, because ultimately we need to have data, real time in clinical practice. I am sure you have already seen the studies on saroglitazar which have been published, like PRESS 5, PRESS 6, and a couple of them which are ongoing, which will be published soon. But what is the feel of it? I am now told that more than 40,000 patients are on this drug in India who are benefiting from this drug. And you can see here that in this registry program, around 2,500 doctors who are clinicians participated. Around 13,000 plus patients were enrolled, and participants were across India. And now the first interim analysis is available on 2,000 of these patients with a 3-month follow-up. And this was done through a CRO, and they looked at look at the compliance data management, and they looked at cleaning the data. So among the database they surveyed, the total number of patients were around 2,000. The mean age was around 53. Okay, 60% of saroglitazar users were male. But however, remember, look at the age where they use saroglitazar. Young people like 22 years old also got it, and elderly people up to 87 also got it. The mean weight was around 71 plus or minus 11 kilograms. However, the mean BMI was much lower at around 26.7. So it was a typical Indian patient, male, 53, 71 kilos, around 26 is the BMI. And all patients were from real-time clinical practice. So what were the split break of these 2,062 patients? Around 90% of them were on anti-diabetic medications. And what was anti-diabetic medicine? They were on 90% on metformin, very, very useful. 70% secretagogues, 36% gliptins, 20% glucosidase inhibitors, 8% glitazones. And a small percentage of 9.6 or 10% were on not any anti-diabetic medicines. Apart from that, the other anti-diabetic medications we look at were insulin 14%, glynides 0.4%, and GLP-1 agents 0.3%. So if you look at monotherapy, dual therapy, triple therapy, and more than 3 drugs. It's a very typical Indian snapshot. Our patients, we rarely give monotherapy. I'm sure in this audience, all of you all treat patients with diabetes. Most of our patients are on 2 drugs. So 42.9% were on 2 drugs, 34% were on 3 drugs, and 10% were more than 3 drugs. So majority of the patients were on combination anti-diabetic therapy, and the most commonly prescribed monotherapy was metformin. What was the patient profile? 35% of people were not on any statins, while 65% of the patients were already on a statins. And you can see the statin users. 72% were using atorvastatin, 28% were using rosuvastatin, and a small group was using either pitavastatin or pravastatin. So look at the distribution of statin used. You can see here 10 milligrams, 20 milligrams, 10 milligrams, 5 milligrams of rosuvastatin, 20 milligrams of rosuvastatin. These are the numbers which are there, and predominantly the most commonly used statin in India is either 10 or 20 milligrams of atorvastatin. So look at the interim analysis. What was looked at after they were given saroglitazar? The glucose and the lipid parameters were looked at. They looked at the baseline A1C. Did it come below 7% or did it remain above 7%? What was the population with diabetic medicines, with without anti-diabetic medicines? What was the baseline TG? Below 200 and above 500. And how many were on statins or without statins? So let us look at lipid parameters. Let us look at the lipid data of 4 milligram of saroglitazar. Okay, baseline triglycerides in 2007 patients analyzed 316 plus or minus 128. It dropped down to 191. So it's a very strong agent which lowers triglycerides. The percentage change was 35.7. Let us look at LDL lowering. It is not that robust, but still there was a significant 16.8% change from 139 to 112. HDL, again you can see a 7.4% change from 39.2, it went up to 41.3. So again you can see a real life situation in the Indian population, just like what the ICMR indirect study picked up. Our HDL is low and triglyceride is high. That's exactly seen in real clinical practice also. Cholesterol 242 coming down to 192, again significant, a drop of minus 19%. And non-HDL cholesterol coming down from 203 to 151, a drop of minus 23. So you can see TG's robust drop, LDL again a robust drop, HDL there is a little upping, and you can see non-HDL cholesterol clearly a drop. Let us look at glucose. Does it lower glucose? 4 milligram of saroglitazar. And let us look at the A1C. From 8.2% it comes down to 7.4%. So an absolute change of 0.7 plus or minus 0.7. So clearly you can see that the A1C drops. Okay, so it is having that little glucose lowering effect, and I would say it's quite substantial. It's like any other reasonable agent which we have it available as a third agent. Fasting glucose comes down very nicely from 174 to 129, so a percentage change of around 23.7%. And postprandial glucose, you can see that is much better. Just like the triglycerides dropped very nicely, you can see that the PP glucose from 260.6 came down to 185.6 and a percentage change of 26%. And you can see not weight, it is not maintained, maybe a trend towards weight loss. So unlike a glitazone, it is weight neutral. It doesn't have any weight gain effect because the glitazar component of it has a dual action. The alpha agent does not allow that rapid weight gain which a gamma agent would have allowed you. So this was the classical analysis. We have now data to show lipids come down very nicely and glucose comes down very nicely, particularly PP and A1C and even the fasting. Let us look at people who go below 7% and above 7%. And let us look at the baseline. If the A1C is at 6.5, at month 3 it will be 6.7, it will come down to 6.5. So an absolute change is seen. But the triglyceride from 296 very, very nicely comes down in the people who are A1C is less than 7% from 296 to 175. A drop of 120. So that's a significant percentage change. So even in people whose glucose is very well controlled, you can see the TGs drop very significantly when you add saroglitazar. Let us look at people whose A1C is above 7%, 8.3, and most of the patients, see only 200 patients were in this group where A1C was well controlled out of 2000. That means only 10%. But if you look at people in India, most of their A1C is above 7%, around 1770, 8.3 is the average A1C plus or minus 1. And you can see the triglycerides again coming down from 319 to 194. A very nice drop of 126. So that's again significant. Let us look at people with anti-diabetic medications. A1C from 8.2 coming down to 7.4. And you can see an absolute change. And without anti-diabetic medications from 8.1 to 7.5. Look at baseline TG below 200, baseline TG above 500. And look at this. Triglycerides 167, month 3 132. And you can see here A1C 8.1, 7.4. You can see that very clearly. Triglycerides above 700. 700 baseline. 117 patients had that. Very high. Comes down to 287. 413 drop. And A1C from 8.2 to 7.4%. Let us look at people with statin therapy. Baseline in month 3. TGs come down. LDL cholesterol comes down despite of statin therapy. From 143 to 1. Because we all know there's a residual risk with statin therapy. And statins are not able to reach their targets many a time. That's another ideal place where you can use Glitazar. HDL, again, it keeps on being low in so many of our patients. Add a little bit of Glitazar, you can see it comes up from 37 point to 40 points. And you can see cholesterol also comes down and non-HDL cholesterol comes down. A1C drops down very robustly. So very clearly you can see without statin therapy also similar data. 1285 to 189, LDL comes down, HDL remains similar, non-HDL comes down, A1C drops down. So you can see here beautifully. Below 200, the TG drop is around 19.3%. Between 200 to 500, the TG drop is 35.6%. And if you see the TG above 500, it is more than 57.9%. I have had a patient of mine who had a triglyceride lipemic serum of more than 2000, getting recurrent pancreatitis. I used Glitazar. The triglyceride came to 8, hardly detectable in the lab. So you can see this is a very, very powerful triglyceride lowering agent. You can also see it is just not a lipid agent, it is also a glucose agent. You can see a very clear drop from 0.1 to 0.8 in people who have a A1C above 7%. Are there any side effects? This was our publication in journals. The 2 publications, Press 4 and 5. Clearly, you can see in the phase 3 clinical trials, gastritis, dyspepsia, pyrexia, asthenia was noticed. But in the clinical trial reportage, no edema, weight gain was seen. No adverse event was reported till date. Significant reduction in triglyceride, LDL and non-HDL. Significant improvement in HDL. Significant improvement in glycemic parameters. And the higher is the TG and A1C, higher is the reduction, which is very, very expected. So what I have tried to do is that we have this agent with us for a year. We have some preliminary data with us. I have just shared with you that preliminary data showing you how robustly this agent is not only able to tackle a triglyceride or a lipid profile, but also an A1C reduction. Thank you for a patient hearing. Any questions?